This is lesson 7.4, unit 7, day 4. We're going to be talking about volume in this lesson. In the past few lessons, we've been talking about a two-dimensional measurement, area or surface area of these. We measured these in square feet, but today we're looking at volume of all the different figures we've looked at so far. Volume is a three-dimensional measurement. It is the amount of 3D space, or how much three-dimensional or 3D space an object takes up. Okay? Now, if we were dealing with strictly rectangular prisms, strictly just basic box shapes, volume is usually length times width times height. Okay, and where this comes from, and I'm going to show you this before we move on to any other formulas for prisms and cylinders. If I were to take a flat surface, like let's assume this is a rectangle that has a length, okay, right angles here, but it's drawn in perspective, so it's laying flat by width. Okay, if I were to take that and duplicate that over a series of layers in a new direction, rather than just length by width, if I were to stretch that and layer it on top of itself repeatedly, okay, we can just use a bunch of different colors here. Okay, and just keep layering it one on top of another. We end up getting this dimension of height that is added in. Well, if I take all of those dimensions of height and stack them up, I get a three-dimensional measurement in cubic units, and that's where we get length times width times height. And so what we can do is duplicate that concept for any base area shape, to where the volume of a prism or cylinder is always B times H, where B is the base area. You might remember that from whenever we talked about surface area. And H is the height. But remember, for cylinders and prisms, height is the distance between bases. Okay? And so when we calculate volume of these kinds of figures, all we have to do is find the base area, or the area of the base shape, and multiply it by the height, the distance between those bases. Well, this is what we would call a trapezoidal prism. Okay? And in our trapezoidal prism, the base is the trapezoid. So our base, area of a trapezoid, remember, is 1/2 base edge 1 plus base edge 2, all times the height of the trapezoid. This is the height of the trapezoid, not the height of your prism. Okay, this is a different H than this H. They're not the same ones. So our base area is going to be found by doing 1/2, one base of the trapezoid, or one base edge, little b1, is 6. The other opposite parallel side is 2. And then the distance between those base edges is 3.5. And that's how I would calculate the area of this trapezoid. But then the height of your prism is this distance between the front trapezoid and the back, which would just be that 2 feet. So our volume is that base area times 2. So that base area works out to be a total of 14. But then our base area times my height of 2 gives me an overall volume of 28. Pardon that interruption. Sorry, our volume is 28 feet cubed, or we would read that as cubic feet. Okay, so to find the volume of a cylinder, it's very much the same thing, but here our base area is a circle. Okay, so for the area of a circle, remember, that's B for base area, pi r squared. So this base area is pi times a radius of 1 inch. If the diameter is 2 inches, the radius is 1 inch. So 1 inch squared. And the height of this cylinder is just 1 inch. So this is a very, very simple calculation. Our volume is 1 squared times pi, but that's just 1 pi, or pi. Base area is just pi times a height of 1. So my total volume is actually just 3.14. It's just pi cubic inches. Okay, that's a simple calculation. I don't need a calculator for that. 1 times pi is pi. And that's about 3.14, or if you rounded to 3.1, that would also be okay. Okay, so that's finding volume of cylinders. Well, we're also going to talk about volume of pyramids and cones. Now, in class, we're going to talk about where this is found, and we're actually going to do these examples in class, because I want to show you a specific reason why we get the formulas that we do for the volume of pyramids and cones. So we're going to skip this part for right now. But I do want to talk about the volume of spheres. There are specific volume formulas we're going to use for spheres. Okay, the volume of a sphere is 4/3, the fraction 4/3 times pi r cubed, r to the third power instead of r squared. This is a lot like our surface area of spheres, but it's 4/3 pi r cubed. Okay, so we're going to take pi times the radius cubed to the third power times 4 divided by 3. That's the easiest way to do 4/3. Multiply by 4, divide by 3. Okay, so when we find our volume here, volume is 4/3 pi times this radius of 3 to the third power. Okay. I can even put that in the calculator all at once. Okay, I can even enter this 4/3 as a fraction with parentheses. So parentheses 4 divided by 3, parentheses, times pi times 3 to the third. And I have to use my exponent button to go to the third power this time. And we get approximately 113.1. This would be cubic meters, or meters to the third power. Okay, and then we could do the same thing here. I'm going to skip over this one, but the radius here would be 3 instead of 6. Which leads me to my final set of examples, where we have composite volume. Now, composite or the volume of composite figures, is a lot easier than the surface area of composite figures. Take number 2, for example. We've seen this picture before, and we found the surface area here, but we want to talk about the volume. Well, the volume of this is simply the volume of our box on the bottom, our rectangular prism, plus the volume of a cylinder, or a half cylinder rather, on top. And so there's nothing to subtract, there's nothing to take away. We just have 2 separate volumes that we can add together. So we're really still doing part plus part equals whole. Okay? And so for number 2, let's go ahead and do that one together. The volume of the bottom portion, any rectangular prism has the volume formula, length times width times height. 9 times 10 times 11. Okay, so our total volume of this bottom portion, I'll call it volume 1, V1, is 9 times 10 times 11, which is 990. But then the volume of this top portion, since this is a half cylinder, our volume of our top portion up here is half the volume of a cylinder. Remember, volume of a cylinder is pi r squared for the area of a base times the height. Well, in this case, the radius is 5, so pi times 5 squared, times the height, which is the distance between these circle surfaces, which would be a length of 9 meters, but I'm going to divide that by 2. And so when I put that all in the calculator, I get an approximate total of 353.4 for my, that would be cubic meters, for my volume of the half cylinder, and I'm going to add that to 990. Okay, so for number 2, my total volume is 990 plus 353.4, which is a total of 1,343.4 cubic meters. Okay? And so that's composite volume. And so we could do that with a lot of different pieces. We'll do some more examples in class, especially when we start talking back to cones and pyramids, but that gives you a start for finding volume.